All right, so we are doing diff this week. So this is a characteristic that shows the different extent between differences between subjects from different groups that have the same ability level. So as we looked at last week for IRT, looking at the discrimination between for difficulty. This week we're going to look at 2PL. So we're going to look at difficulty and discrimination, basically showing and using diff to show us the extent to which an item in our set may be measuring different abilities of members from different subgroups within a certain data set. So for this, we need diff R. I've already installed this. And then I'm just going to library diff R, and then we're going to do a couple plots at the beginning. So ggplot2. So unlike last week when we use Rash, I'm using LTM to run for my IRT this week. So signifying my data set and that I'm pulling from one latent variable here. And we're going under the pretenses of the IRT parameter. So following this, we're going to get the difficulty and discrimination parameter estimates. So last week we were just looking at the difficulty. This will show us the B and A parameters. So the difficulty is here and the discrimination's here. But just like last week, I'm going to look at the ICC, IIC, and then the test information curves before we run the diff. So we can look at all of our different items here. I used a set that had 15 items and then 2,000 randomly generated responses in Excel. And we're going to be looking at item 1 later. So item 1 is going to be my variable for gender. And then these are a bunch of the different items with the binomial 1 or 0 answers. So we can look at the item characteristic curves. Most of these are somewhat normal. We can see ability theta at the bottom and then the different slopes. And then same thing for ICC curves. So just like last week, seeing the differences between each item and then running the overall function. So looking at the test information function, then we see that ability kind of peaks a little bit below 0, but overall has a fairly normal distribution. So for this, like before I said, diff can help us signify unexpected behaviors and for items on a test. So which items we might expect to have some kind of weird responses. So items are not going to display diff if people from different groups have different probabilities to give a certain response. So you're going to see that over the different abilities. But if an item does display diff, it means that people from different groups who have the same true ability have different probabilities of giving a response. So they may actually be on the same, so they may actually be ability 1, but they may be giving different responses. So as explained with all those IRT things, just there's different ways you can look at diff, and you don't necessarily need to use IRT, but you can use IRT-based methods to assess diff. So you can use 1, 2, or 3PL models, but for this I'm going to use a 2PL. Since I'm using IRT, you can use uniform and non-uniform. You can look at different groups, and for both of these you can use different functions, LRT, Lord, and Raju. if you have two groups, and then if you have more than two groups, you can use different pairwise comparisons, and then the generalized Lord test. But I only have two groups, and so I'm going to be using, like I said before, gender, so men and women, which I'm signifying in item 1, and my focal point is going to be ones, which are going to be males. So here I'm using the diff Lord function, one of the options for running for an IRT approach, signifying my data set here. The column is my group, so gender from the data set signified by item 1, a 2PL model, and then focal name of the male respondents. And so yeah, this is the uniform diff detection for IRT, and then the significance level of 0.05 is the default, so I don't have to type any of that in for extra. So when you run this, you can see the output. You can also do item purification. I chose not to do that. There's a bunch of different options that you can add to this different function. I did not use anchor items, but Lord functions under a chi-square. I'll explain more of it in the next part because I'm going to compare a bunch of different methods. But so you can look at the p-values here and see which items may be problematic. So item 4, p-value, so is significant. So you can also see it down here, items detected as diff items, item 4. And another way we can look at this is actually to plot the function. And you'll see that once again, item 3, which think of, we had to omit item 1, so this is actually item 4, but it's 3 to look at it across here because we're comparing from that first group. So all these are shifted, so this is 15, 14, 13, etc. So item 3, problematic up here. But if you want to look at a bunch of different methods, you can just use the DICO-diff function and then plug in a bunch of those different methods kind of talked about above, depending on if you're using IRT or not IRT. And then you're signifying once again the data, my gender, my males, and then methods. So you could use STD, which is for standardization, and this looks at the different proportions of correct responses in each group for each value of the total test score. And so these are all compared, and then the resulting statistics from this, if I were to run it in something that looked like this, ends up being a standardized p difference, and so it represents an average of the difference of all the success rates at each test score. And then this compares your focal group and your reference group. And then logistic is for logistic regression. So logistic model is going to be fitted based on the probability of answering a test item correctly. And this is also based on total test score, what group you're in, and the interaction between these. So for uniform diff, this can be detected by testing the main effect of a group, and then in non-uniform diff, this is detected by testing that interaction. And then Lord, just as discussed above, so a chi-square is based upon your null hypothesis that there are equal parameters in both groups. And so the statistic with a chi-square distribution is going to fall under the null hypothesis. And then the Raju is looks at the area between the item characteristic curves. So it's comparing for the focal group and that reference group. And then it's going to give you a z statistic, and that is also based on the null hypothesis that the area between those two curves is going to be 0. And this is important in 3PLs especially because this assumes that the guessing parameters must be assumed to be equal. And we don't have to worry about that. I'm in the 2PL, so I run this here, and the output's cool. It'll show... So it'll actually show the diff and no diff comparison against all of those things. It'll show the different methods you used, what variable, the matching variable are the test scores. Once again, didn't pick anchors, your significance level, the threshold, so all that information for the parameter estimations. And then you can look down here to compare all of these. So for each item, you can see across if there was differential item functioning. And so once again, from above we found the item 4. We're not finding it for standardization, but we're finding it for logistic load and Raju. And then here we see that item 13, which is this item. We find diff for logistic functioning. So pretty cool to see that across. We see that item 4 might have that different probability of giving a certain response, even though the ability of the person is the same. So we'd look at that. We want to go back and look at that item. So I used the uniform diff, which is the simplest type, but that's basically looking at how there's dependence across theta, so the latent trait down here, so on our x-axis. And then the various item of interest will basically give one group an advantage across all levels of ability. So IRT will show this on the item characteristics curve, and then you can also look at this through these different functions below. All right, bye.